Okay, so what they're asking us about in this is they're talking about something called the linear correlation coefficient, which is R. I have no idea why we use R, but we did. So the linear correlation coefficient is R. And in your notes, I explained it a little bit here. Here I say the linear correlation coefficient R. This is your exam 4 notes right here. And if R is close to 0, it means no linear connection. Correlation is just connection. If R is close to +1, it means a strong positive. Close to -1, strong negative. Let me show you an example with some dots. I think that'll be most helpful. So let's do that. So okay, so let's look at some examples. So if I have a bunch of dots that kind of, well, here, let's, oh, whoops. Sorry, guys. I just clicked the wrong button. That was not good. Let me try again. Sorry. Oh, whoops. Sorry. Let me try. I'm sorry. I'm having a little trouble here. If I can find it again. There it is. I think that's it. Yes, we're back. Sorry. All right. So now, if I have a bunch of dots that like perfectly, let me put it up here, that perfectly line up. I mean, they are in a perfect line. Like that. That would be R is 1.0, positive 1.0. If the dots go down, in almost a perfect line, that would be R is negative 1.0. Okay. If the dots, let me bring this one down here. If the dots kind of go up in the positive direction, but they're sort of mixed. So they're kind of a straight line, but they're not perfect. That would be R is maybe like, I don't know, 0.8 positive. And if the dots go downwards in kind of a somewhat, that might be R is negative 0.7 or something. You know, they're a little looser. So the looser the dot, so R, how about I do it this way? Another way you could think of R is R goes from -1 to positive 1.0 with 0 in the middle. So this is the scale. This is R. This is the R scale. And positive, perfect line, meaning, let me try that again. Perfect line, perfect line, lined up dots, line goes up to the right. And down here, perfect down. And then in the middle, the dots, no, not lined up at all. Yeah, so as you look at, so I could give you some more examples. Like if we had over here, we change it up. If we had an R where the dots are like pretty darn random, like bonk, 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 bonk. They're just like all over the place. You know, they're not lined up at all. This would be R is basically 0. I mean, it's not going to come out 0. It might be something like negative 1.3, or that's not correct. Negative 0.13. That's basically 0, right? That's super small, or R is positive 0.08. You know, basically 0 is what we're saying. Something really close to 0. 0.08, you know, 0.13, you know, close to, like, think about money. It's like no money. 13 cents, 8 cents. You basically have no money, right? Whereas this is down $1, up $1, perfect lines. Or this is 80 cents. This is really 80 cents. And this is 70 cents. Down, because this, they would represent a line going down. A line would go through the middle of these going up, right? You getting the idea? So on the extremes, positive 1 is a perfect line going up. Negative 1, the dots are perfectly lined up going down to the right. And then if the dots are a little looser, but going up, positive 0.8, a little looser down, maybe negative 0.7, these are basically 0. Now, also, one more situation I need to show you about. What if the dots do something like this? Hold on a second. What if the dots do something like a clear curved pattern? That's curved, isn't it? Curved pattern. Well, R is going to be basically 0. Why? Because it's not a line. All we're testing for is this a line? Remember, it's called the linear correlation coefficient. It just tests if there's a line. There could be some other pattern that's not a line, but if so, when you do on our calculators, in a minute, we'll do these on our calculator, and you'll read about them in official studies all the time in professional settings. They talk about the correlation coefficient. And if it comes out to be 0, that the linear correlation coefficient, that just means that it's not a line pattern. It could be some other pattern. It could be a curved pattern, but it's not a line pattern. So the R is a measure of how closely the dots fit a line, how much they're lined up when you do data research. And positive, if the line's going up to the right, negative when the line's going down to the right, positive if the line's going up to the right. Okay, so question is, what if you get 0.52? Here's back to this actual question number 3. What if we did some kind of study and the R came out to be 0.52? That's what they're saying. R equals 0.5. What does that tell you? The slope of the regression line. The slope of the regression line is, honestly, I'm not 100% sure how specific they want us to get on this question, but it's positive, isn't it? Positive. So that would be positive. We'll say positive. So the slope is positive. The R tells you the slope, and the slope in this case is positive. So there we go.